Okay, so good morning, everyone.
Good morning, sir.
Po, sir.
Good morning po, sir.
Good morning po.
So maybe you know that we have a different time zone, right? Kita nyo may
Yes
ilaw
po.
sa likod ko. Okay, it's nighttime here. So it's 11:33 there in the Philippines, Wednesday, right? And it's 10:33 in the evening here, Tuesday. So I'm still in this so-called Tuesday, okay? 02/22/2022. So this is Chem 137, okay? So to formally introduce myself, I'm Elmer Mojica. Okay, I will be your professor in 137. So I'm not sure if we're going to meet every Wednesday and Friday. So it's up to you because once I make the materials available in Canvas, so right now, hindi ko alam kung nakuha nyo yung materials sa Google Meet, okay? But I will use the Canvas instead of this, what we call the Google Meet, okay? So medyo bago pa lang ako sa pag-use ng Canvas because we have a different LMS in the main school that I'm teaching here. So I don't know how you end up in this section because aside from section D, there is also another section of Chem 137 lecture. That is, if I'm not mistaken, section V. Okay? So, ewan ko ba't napunta kayo dito sa section Dymos kung pwede naman kayo doon sa section Voltes 5. Okay? So, to formally discuss, I'm going to show to you this course guide. I'm not sure, as I have told you earlier, hindi pa ako sure doon sa access ninyo sa Google Meet, but all these materials that I'm showing you, I will make them available doon sa Canvas natin. Hindi ko pa kayo nadadagdagan. I'm still getting used to this Canvas thing. So the material that we have, no, that's not the one. Here, the course guide. So this is Chem 137, Modern Analytical Chemistry. So the course description here is this course on theories and principles of modern methods of chemical analysis is designed to give you knowledge about instrumental methods of analysis. So emphasis is given on the principles of instrumentation, instrument components, limitations of measurements, and the selection of appropriate techniques for specific analytical problems. So maybe the most important word here is the word modern, because you already get this so-called analytical chemistry. Maybe it's not really analytical chemistry. Ano yung definition ng Chem 32 nyo? Is it
Quantitative inorganic analysis po.
Okay, but that is really your, we could say, analytical chemistry. Okay, so the difference that we have here is during that time, you use the so-called classical or traditional analytical chemistry, the so-called wet chemistry. I think the introduction that I will have after discussing to you the course guide is doing chemical analysis. Okay, so helping you to transition from the Chem 32 to Chem 137, although the prerequisite of this course is Chem 111. So the schedule that we have is 11:30 to 1, which I think is not really good for you. Baka ginugutom na kayo by that time. Now for me, until March, that will be 10:30 to 12. But comes March, when the daylight saving times ends, okay, it will be from 11:30 to 1 o'clock in the evening here. Okay, so to make sure that you will be guided, okay, or ano yung kailangan yung gawin para pumasa sa course na to, you have to meet these learning outcomes. So explain the basic principles involved in a variety of analytical methods. Recognize standard organizations and their requirements for accreditation of testing laboratories. Demonstrate ability to construction of calibration curves. Interpret and apply the performance characteristic or figure of merits of instrumental methods of analysis. Recognize the basic components of instrument used in chromatography, mass spectrometry, molecular spectroscopy, atomic spectroscopy, electroanalytical methods, and radioanalytical methods. And then last but not the least, solve problems about the practical applications of instrumental methods of analysis. So those are your guide, okay, for you to pass the course. So the coverage is given here. So meron tayong tinatawag na timetable. Okay? So we need to finish in 2 weeks the first module, which is just the introduction. And you will be guided in the module to make sure that by the end of the module, you meet the objectives. Okay? Now, the advice given to me is we don't really need to meet every meeting. I don't know what's your opinion on that. Okay. All I can say is I will make available all the links to my previous 137 lecture. So this is my second time to teach 137 in UP Los Baños. Okay. So I used to teach there. I think, I don't know how old are you, but I think you already exist. I think the last time I was there was 2005. Okay. I never taught 137, but I taught 137.1 during that time. So I'm still familiar with the experiment that is being done, although that is different now because I think it's online. So the method that we have will be online. And I think I have a request. Can somebody organize some sort of a group chat in Facebook so that if you have any question, you can always ask that, but try to understand that I may not be answering it, especially if you put some questions in the afternoon there. I think the earliest that you can get will be evening. Okay? So pag nag-type kayo ng question alas 3 ng hapon dyan, milagro kung sumagot ako kasi most likely nasa kama ako natutulog. Okay? But at least if there's any announcement that we need to do, I think it's easier for you to be in contact because that's the most important thing that we have. And I learned during an online class is to always keep communication with the students open, especially if something happens to you and you cannot take the quiz. Okay? I know I will be informed and I will understand the situation that you have. So maybe by the end later on, kung sinong mag-volunteer, I don't know any of you. That's the thing. Okay. So this will be your guide as we go on. Okay. And in some instances, you will be given, I think, quizzes and problem set. So usually the problem set will be calculation, the quizzes, there's some calculation, but most likely concept question, multiple choice or true or false. Okay. So you can only answer the question if you watch or read the material. You watch the videos, the lecture videos that I will give to you, or what we call read the material. Now, should we need to meet synchronously, I'm open to that. Okay, but I understand that some of you will not be able to meet. Okay, so as much as possible, like what I'm doing right now, I will record the lecture that we have. So here, the synchronous, asynchronous, synchronous, asynchronous here. So as you're going to look at here, introduction and then QA, and then we go to the first one, chromatography, separation techniques, spectroscopic techniques, mass spectrometry, electroanalytical, and then the miscellaneous techniques. If you want to go ahead, when I, what we call update the canvas, I will make the link available to everybody, the whole lectures that I have from last semester. Okay? So questions so far, pasensya na yung maingay. Bakasyon kasi ng anak ko. Question, huwag kayong mahiya.
Wala naman po.
Okay? So 23 right now, so that means 3 is missing. So I have not what we call uploaded the material that I have so far because I'm still getting to know this what we call canvas. Okay, but what I'm going to do right now is just some sort of a lecture on this so-called chemical analysis. Okay, just to give you an idea on what you expect. Okay, and feel free to ask questions. I would appreciate if you could at least ask some question para hindi naman lagi ako nagsasalita dito sa harap ng sa laptop ko. Okay. Tapos parang naglalaro ng spirit of the glass, magtatanong sa inyo, andiyan ka pa ba? Andiyan pa ba kayo? Okay? Teka lang ha, aanin ko lang to anak ko. Okay. So doing chemical analysis. So this is just some like an introductory for what we call lecture that I gave last semester, and I usually give to any students that I teach in instrumental analysis. Okay, so we know chemistry can be divided into this field, and the field that we have is analytical chemistry. So for those who are still trying to find a thesis problem, this is my advice. The easiest of all is the analytical chemistry, because whatever you got as your result, that's it. All you need to do, process it, process the data, interpret it. You cannot do anything. Organic chemistry, you're going to synthesize. Okay? Can you synthesize with limited materials? Think again. In organic chemistry, the same thing. You can do some synthesis using all the elements except carbon in the periodic table. Chem is a little bit high-end, while biochemistry, I think, is that's one of the strongest fields that we have there in UP Los Baños. But me, being biased, why? Because my specialty is analytical chemistry. So kung ano yung na-analyze mo, yun na yun. Wala kang magagawa. And all you need to do is to interpret it. And to tell you frankly, it's easy to get data. What's the hardest part? What's the harder one? Interpret it, process it. Okay? Try to make a story out of the data that you make. But usually that's what analytical chemistry do. Okay? So analytical chemistry, this is the second series that you have. The third one will be the 137.1, or if you are in Ag Chem, you have what? 131, right? Anyone here agricultural chemistry?
131 and 133, sir.
131, 133. Yeah, 131 is technical food analysis. 133 is, if not mistaken, is soil and pesticide, because I'm on agricultural chemistry. I have a BS agricultural chemistry way back then. Okay, siguro hindi pa kayo nag-exist nung nag-graduate ako way back in 98. Okay? So, analytical chemistry is a scientific discipline that develops and applies methods, instruments, and strategies to obtain information on the composition and nature of matter in space and time. So that's according to the Working Party on Analytical Chemistry of the European Federations of Chemical Societies. We can also define it as a metrological discipline that develops, optimizes, and applies measurement processes intended to produce quality biochemical information of global and partial type from natural and artificial objects and systems in order to solve analytical problems derived from information needs. So if we're going to look at the definition of the analytical chemistry, this is what it is. It is the science, okay, of extraction, identification, and quantitation of an unknown sample. What does extraction do? Anyone? Anong ginagawa mo pag nag-extract ka? You're trying to separate something. Okay? So let's say you have this term analyte and it is in the sample. So if you want to separate your analyte from the sample, one way to do it is to extract it. And then you try to identify in case you don't know your analyte. And then you quantify. Okay? And later on, you will know the qualitative and the quantitative analysis. So analytical chemistry also deals with the methods for determining the chemical composition of samples. That's why you can do anything if you have the result, because it is at it. Yeah, it is at it is. Kung ano man yung composition na wala kang magagawa. Okay? Now the main aim of analytical chemistry is the obtainment of as high metrological quality as possible. So is as true as possible analytical information with as low as possible uncertainty. So solving analytical problems derived from chemical or biochemical information needs posed by the clients engaged in a great variety of activities, health, general, and agri-food industry and the environment. I think analytical chemistry is what I can call the practical chemistry. Right? Kasi anong end game kapag analytical chemist ka. You can be in the quality control, you can be in the quality assurance, okay? You can be in the industry, you can be in hospital, you can be in any fields that do analysis. So yan yung, we could say, advantage of analytical chemistry. In case you still don't know, what do you want to be? Okay? Lahat ba kayo may thesis na ginagawa? Ha?
Wala pa po
Wala
sa
pa po,
Wala
sir.
pa po, sir.
Naghahanap pa kayo kung sino yung magiging advisor.
Wala pa po, sir.
Okay? So, the thing is, right now, you can go in organic chemistry. You can go in biochemistry. Okay? If you want computational, yun yung pinaka-simple ngayon because you still don't have the in-person, you can go in PChem. Okay? Analytical chemistry, you have to do in person. Although there's still some what we call computational aspect that you have there. Okay? I myself, I was trained in analytical chemistry, but I still use computational chemistry to provide theoretical explanation to any experimental results that I have. Okay? So when you have analytical chemistry, although ang main forte niya yung analysis, you still have the synthesis. So where do you do synthesis? Di ba sa orgo? Orgo kasi tawag namin dito sa organic. Okay? Or is it still 43, 44, and 140? Yan pa rin ba yung numbering?
Yes po.
Yes po.
So, nasaan
Yes.
na kayo ngayon? Tapos na kayong 44. Dapat lang. Right? Tapos na kayo lahat ng 44?
Opo.
Yes po.
If I'm not mistaken, nasa 140 na kayo. May 140 ba dito? Nagwa 140 na yung iba dito?
Tapos na po.
Tapos na. Okay, and I know the teacher there. Okay, Ma'am Gladys. Okay, so even though you do analysis, you're still a theory there. Because whenever you analyze, you have to put theory. Ano bang mangyayari kapag may result ka? O ano yung masasabi mong hypothesis na ma-elevate sa theory? And then you have the application. So nandoon pa rin yung ibang, let's say, component na makikita natin sa ibang chemistry. Okay? So the thing that you need to consider when you do analytical chemistry, yung tinatawag natin internal interfaces na field at yung tinatawag natin external interfaces. I think this is not only true for analytical, but also for the chemistry, right? In case you don't know, I have a task that asks each of you doon sa Google Meet to introduce yourself and to answer the question, why Chem or Ag Chem? Because chemistry is what? Pag sinabi nating CS, it's a central science. So if we're going to look at the internal interfaces of analytical chemistry with other chemical areas, it can be in the organic, inorganic, physical, and applied chemistry, including chemical engineering. Okay, now you can also put there in terms of what we call external interface. So this is with other fields or sciences or discipline, biology, biochemistry, mathematics, physics, or engineering. There's still analytical chemistry. The research that I do here, some works on environmental science, some works on food science, some works on biological science, but they just use analytical chemistry because the specialty that we have is the use of instrument to analyze chemical of interest to these different fields. Okay, so in the enzyme, let's say here, you can determine the enzyme activities or the drugs of abuse in biological fluids. Okay, or a passive one in chemometric developments for data processing or the use of immobilized enzyme in analytical process. So if you're going to look at this, ito siya. It can be working with internal interfaces or external interfaces. So internal interfaces is just the other branch of chemistry. External interfaces yung other discipline. At being the central science nga, okay, it plays a role in other discipline. Andun lagi yung analytical chemistry. Because when you said analysis, especially the word chemical before analysis, most likely you're doing analytical chemistry, right? So geology, you want to analyze, let's say, the age of the soil or the metal that is present in the soil. So you need analytical chemistry there. Okay. You go to engineering, you want to look at the strength of the material that you have. You have analytical chemistry there. In medicine, you want to look at the result, the blood test, the urinalysis, That is classic analytical chemistry. So if you're going to look at the roles of analytical chemistry, it plays a lot of roles. Some of them vital roles. Chemistry, biology, biotechnology, forensic science that we have here, food science, material science, medicine, and environmental science. When the human genome was sequenced, they used analytical chemistry, the capillary electrophoresis. If you want to determine the pollutants, you use analytical chemistry there. Okay, in medicine, the tests that you have, the lab results that you have, you utilize analytical chemistry there. In the industry, okay, analytical chemistry is used to test the raw materials and assure the quality of finished products. Okay, yeah, that's why you have this what we call QA and QC. And unfortunately, some of you will end up like that. And some of you will complain, just like batch of myself, that it is a very routinary and boring job. Okay. Environmental quality, the same thing. The different acts that we have there, like Solid Waste Act, the Air Quality Act. So some of these industry or factories, they want to make sure that they don't violate them. So they have to do this environmental analysis of their samples. Forensic analysis, I don't know how advanced you are there. You analyze, okay? You do analysis using analytical chemistry. So these are just some, okay? So when you do analysis, it could be of two forms. Qualitative, the one that answers the question what is or are present. It determines the chemical identity of the species in the sample. Quantitative analysis answers the question how much of the sample or the analyte is present in the given sample. Is a determination of the amount of species or analytes in numerical terms. That's why math is heavily involved. Now, the common rule that they have, in order to perform quantity, you have to do qualitative analysis. Why? If you did not determine the presence of your sample, why analyze how much of the sample is present? Kung absent na nga dun, ba't ka pa magpa-quantitative analysis? Okay? One need to know what it is and then select the means to determine the amount. So maybe this is not new to you. So ito yung tinatawag nating classical, traditional, or we could say wet method. So in the traditional classical method, you have chemicals for separations as precipitation, extraction, and quantitative analysis by color, odor, or melting point. So you have two main methods there, gravimetric method and volumetric method. In the gravimetric method, you use mass. In volumetric method, you use volume. Ano yung common volumetric method na ginawa na ninyo? The classic, what? Ginawa nyo yan sa 32.
Titration.
Okay? The classic titration. Okay? You can do titration based on acid base. You can do titration based on not gravimetric, precipitation, redox reaction, or yung tinatawag natin compleximetric reaction, yung I don't know if you know EDTA. So that's what you did in 32. So what you're going to do here of this type is to learn the so-called instrumental method. Yan yung nagsasabi nating modern method. So here you use an apparatus or what we call instrument. Don't ever use the word machine, right? So in instrumental method, you use an apparatus to measure the physical quantities of the analyte, such as absorption, fluorescence, and conductivity. So this is the three common one. Kulang yung letter R dun. You have spectroscopy that look at the interaction of light with matter. You have chromatography, which is really a separation process. And you have electrochemistry that look at some physical properties like current and voltage. Okay, and I'm going to discuss some of this one. Maybe this is new to you, but if I'm going to follow, you already did this at this time. I think this one is in 32. This one is in 43 or 44. And this one is, what is your Gen Chem? 17, 18?
18 po.
18.
19 po.
Huh?
18, 19.
18, 19. Because during my time, it's 15, 16, 17. Now you may ask, what are those? So in 32, maybe meron kayong ginamit na Spectronic 20. I don't know if it's online, anong ginagawa niyo. In your 43, 44, you did the TLC, right? What's TLC? Tender loving care? TLC, thin layer chromatography. And then you may ask, where did we use in Gen Chem electrochemistry? So that is in the form of your so-called pH meter. So they're not really new to you. You just don't know what methods they are. Okay? Hindi na bago to. So if we're going to look at this, so we can divide them. The classical method and the instrumental method or the modern method. So the classical, pwedeng quali, pwedeng quanti. So if it's a quali, that's a typical chemical test. Like your, I don't know if you did it, cation analysis, right? It's qualitative. Doon sa cation analysis, you can test for the presence of the ion. Kung soluble sila, you use the plain test, like sodium giving you intense yellow. Am I right? Ano yung
Yes
apple
po.
green?
Yes po.
Anong element yung apple green? Naalala niyo pa? Is that potassium? I know calcium, I think is a brick red. Yan yung term namin yung sa 17 kami. Nung nagtuturo ako ng 17 dyan. So that's qualitative. But you can also do quantitative. So ito yung gravimetric analysis, yung precipitation method. Tapos yung volumetric titration or titrimetric method. So that's a quantitative analysis. Now in the instrumental method, you can either do spectroscopy or the separation analysis. And there you will have the deep, what we call methods that we have. Okay. So precipitation method, if we're going to look at the gravimetric method, so I think you just have to use here the solubility rules. The one that is going to form insoluble. So you mix, let's see, you want to determine chloride. All you need to do is put silver ion on it, and you can determine the amount of the chloride. Or if you want to determine the silver ion, you just add the chloride and they form, or they precipitate as silver chloride. Do you remember any argentometric method that you use? It's a combination of gravimetric and titration. Right? Tandaan nyo pa yung mga ball hard? Anyway, the gravimetric method that you have is like this one. So you have solid soluble salt containing lead 2+. So all you need to do is you're going to add, let's say, either sulfate ion, or if I want it to be colorful, dichromate ion. So a lead sulfate would precipitate into, I think that's a white precipitate. If it's a lead dichromate, then that's what we call the yellow. So you filter it, you weigh, okay? your solid lead sulfate, and then you put some sort of a relationship in terms of their chemical balance, balanced chemical reaction. Now, gravimetric also has this so-called volatilization method. So here, inaano lang yung mga na-volatilize, and any loss on that, okay, can be related to the analyte that you're looking for. So a gravimetric method in which the loss of a volatile species give rise to the signal. In this, the analyte or its decomposition products are volatilized at a suitable temperature. And usually the volatile product is then collected and weighed, or alternatively, the mass of the product is determined indirectly from the loss in the mass of the sample. So as you could see here, change in mass or determination of mass, giving you the gravimetric method. Volumetric, that's the classic titration. Attention na rin sa wang-wang. That's how living in New York is. So volumetric method, the common root word there is volume. General term for a method in quantitative chemical analysis in which the amount of a substance is determined by the measurement of the volume that the substance occupies. It is commonly used to determine the unknown concentration of a known reactant. Okay, so commonly the one that is being used is titration. So I think everyone, I don't know, everyone know what titration is, right?
Yes, sir.
Yes po.
Now the next question is, nakapag-titrate na ba kayo?
Yes.
Opo.
Yes
po.
Yes po.
Face to face.
Ang titration na ginamit nyo ay yung mouse, ang hawak nyo, hindi yung kamay nyo.
Nakapag-lab pa kami, sir.
O nakapag-lab kayo, yung iba.
Apo.
Because ito yung ano ko dito sa isang yung big shot na professor from another university. He wants to eliminate the lab. Then I asked the question, so how are you going to teach the laboratory skills that they need when they go to industry? It's not easy to be trained titrating by using a mouse. Okay? And I think kung meron kayong online, yun yung ginagamit nyo. Titrate this amount, tapos gagamitin nyo yung mouse para makontrol yung volume. Okay? So that's the sad thing. Nadali na nga kayo ng, anong tawag doon? K-12. Tapos nadali pa kayo ng pandemic, right? So I know, okay, what is happening to you. So in case you're not familiar on the titration, so you have here the burette and a receiving class. In the burette, you have there the so-called titrant. And here you have the so-called analyte. So the titration that you have is based on the acid base. So that means this can be the acid, this can be the base, or this could be the base, and this is the acid. It can be a redox titration. It could be the reducing agent here, oxidizing agent here, or vice versa. It can be complex formation titration, like what you use using EDTA. You're familiar with EDTA?
Yes.
Okay.
Yes.
You can also have a precipitation titration, wherein when you mix your titrant with the analyte, a precipitate form. And if silver is involved, you call it argentometric. So ano yung mga argentometric titration na alam nyo? Anyone?
Vol hard more.
Full hard. Ano
Okay,
pa?
more.
More. Ano pa? Yan ang na ano nyo?
Isa pa. Wait, ano?
Yung
I don't know if you did, if you heard this, payhans. So these are just some. Okay. So whenever silver is involved, specifically it's called argentometric. Okay. And when you do that, you can have a calibration curve like this one. I don't know if you do it, but this is what? The raw data. Then what is this one? Pag kinonvert mo to dito, anong tawag dyan? Anong plot?
first derivative.
Very good. That's the first derivative. Now, pag kinonvert mo pa ito papunta dito, anong tawag yan?
Second derivative.
Yan yung dyan tawag na second derivative. Now, how about this? What do you call this plot? Anyone? I know it's not being done in UP, LB, but this is what we call a grand plot. Okay? So you put their volume versus, if you're going to look at this, the volume of the base that is added times. Okay, if you're going to look at that, the pH or the concentration, or 10 raised to the negative pH, isn't that equals to the concentration? Tapos mayroon pa tayo tinatawag na grand 2 plot. How does the grand 2 plot looks like? Ganito naman. So straight line yan, tapos pag ganito. There's a lot of things that you do, but what they do is they give you a clear picture of your, anong tawag yan? Equivalence point. In fact, there's what we call the method that they call derivative spectroscopy. What does the derivative spectroscopy do? Whenever you have an absorbance, you convert it to first derivative and second derivative and see if you can make something out of that data that you have, especially if you're trying to compare two samples and you want to differentiate the two samples from one another. Maybe if the absorbance is not enough, then you can get the first derivative. Because what is this really exactly? Anong tawag natin dito if we put it in terms of derivative? Anyone? Ano to? Kung ito ay first, kung ito ay second, anong derivative to?
Zero.
It's a zero derivative. Okay? Now, instrumental methods. Speed can be automated. Okay, instrumental method, they're fast. You can automate them. That means you have a high sample throughput. So when you say high sample throughput, maraming sample na pwede mong analyze at the same time. It is sensitive. You can use trace or ultra trace analysis. Have you learned that in your 32? The difference between the trace and ultra trace analysis? I think you have that. You can have the selectivity, accurate in the presence of many components. So even though it's in a mixture, you can have a method that is selective to your target analyte. And you can have instrumental method reproducible. What does reproducibility means? Kahit ulit-ulitin mo, ganun pa rin yung labas ng results mo. Reliable and objective. Now, the main advantage of instrumental method, you can use small volume or small sample volume, ml or milligram level. Okay. Disadvantage, well, mahal. The more high-tech the instrument is, okay, the higher is the cost. And it's a little bit complex. Okay? Sabi nga sa Facebook status, it's complicated. But right now, they were able to simplify it. So all you need to do is just push the button or let's say follow a certain direction. And one thing that you have there is maintenance. Now, I cannot ask this question to you kasi wala kayo sa LB. Kasi yung una kong tanong, nag-brown out pa ba sa LB? Kaso, wala kayo sa LB, di ba? You are scattered around the country. Okay? Now, what are the instrumental methods that we have? So we can look at the properties. We can look at the one that is emission, like emission spectroscopy involves fluorescence, phosphorescence, luminescence. You will learn about that. The atomic emission spectroscopy, or the other one that is common. This is radiation absorption. So you have here absorption spectrophotometry, like absorbance, NMR, electrospin resonance, and AAS, atomic absorption spectroscopy. You can have scattering that include Raman spectroscopy and turbidity, refraction, which is refractometry and interferometry, diffraction, which is X-ray and electron spectroscopy. You can have radiation rotation, which is polarimetry and circular dichroism, or you can have electrical potential like potentiometry, charge, coulometry, current, which is voltammetry, that's include amperometry and polarography, electrical resistance conductometry, and other stuff. So whenever you have instrumental methods, they take advantage of the physical properties of the target analyte that you have. It can also be this way. It's just the same as the one as the previous one. Mas specific lang yung instrumental methods na meron dito. Okay? Now, I think the simplest one that I could give you is this, electrochemical methods. So in the electrochemical methods, is anything that has a redox. You're familiar with redox? Familiar ba kayo, class, sa redox?
Yes.
Yes.
Ginagamit pa ba si Leora at si Jeroa?
Opo.
You still use that? So, meron kang potentiometric analysis kung saan yung analyte mo is part of the galvanic cell. So, sa potentiometric analysis, nag-generate ka ng voltage due to a drive of the thermodynamic equilibrium. So, yung voltage na synonymous doon sa potential. So, yung amount ng voltage mo depends sa concentration ng analyte. Now, pwede naman voltammetric analysis kung saan ang naano mo doon ay yung current. So, when voltage is applied to the cell, okay, current would flow. And the conditions of the electrolytics are such that the magnitude of the current is directly proportional to the concentration of the analyte. So, ito yung common na electrochemical methods. And you have here your pH meter. Now, what if I told you that your electrochemical method has founded $1 billion industry? Would you believe me? Ano yung product na yun na worth $1 billion? Anyone? Nandyan siya. Ano sa tingin niyo? Ano yun? Ano yung $1 billion industry na yun? While I get water. Ano? May sasagot? Ano sa tingin niyo yung product yan, yung $1 billion industry? Pwede niyong i-type kung nahihiya kayo marinig yung boses niyo. Anyone? Cold farmer? Lahat ba may cold farmer? Lakta. Maaring hindi pa kayo gumagamit nito, pero yung mga magulang niyo, ito. Here in the US is $1 billion industry. Pasensya, padaanin na natin yung wawang. Imagine yung ano ng pandemic, sunod-sunod yan. Okay, so go again. Here in the US, this is $1 billion industry. Why? I spent money on that. So imagine how many diabetics you have around the world. And they have to maintain the sugar level that they have. And the principles behind that is what we call amperometry. Okay. BP monitor, hindi naman lahat ng ano sa bahay meron nun. Diba? Eh ito, pag diabetic ka, meron. Ako meron yan sa bahay. Meron ako dito sa bahay niya. That's why you want to get rich, solve the problem of diabetics. And when you solve that, invest on security because you will be killed by the industry that you will kill with your product. Right? Pag sinabi mo, na-solve mo na yung fuel crisis by inventing some machine that runs on water, ang daming industry or ang daming country ang magko-collapse overnight. Okay? So that's electrochemistry. Spectroscopic method. So this is the one that interacts with light, or specifically electromagnetic radiation. Are you familiar with the electromagnetic radiation spectrum? The visible light is only one of them. Right? Ano pa yung ibang EMR? IR, ultraviolet, cosmic rays, pero hindi na tayo pupunta doon. Okay? So maybe we will just use the one that has light and IR and UV. So the basis that you can have there, it can be absorption based, like your atomic absorption or molecular absorption or NMR. You can also have the so-called emitted or scattered. So if you use emission based, that's the fluorescence. This is the atomic emission. If you have what we call scattered, then you have Raman method. Okay, so these are the different spectroscopy that you have, the usual wavelength range in the electromagnetic spectrum, and the type of the transition. You have the absorption, right? It can be UV based, UV is ultraviolet, then you have visible. Now you can have emission if your sample is fluorescent. Now, if you have infrared and Raman scattering, what do you have? The vibration. Wala yung ano to. Wala. Nawala yung pad ko. Okay. So yung nag 140 na dito, you're familiar with IR? Di ba may nag 140 na dito? Nagsabi kanina. So let's say I'm water, right? Ewan ko, hindi yata kita eh. So if this is the oxygen, you have what? The hydrogen here, so you can have what? Anong tawag dito? Dun sa nag-IR na. Or dito.
Oh, it's stretch.
Okay, so you have your This one, symmetrical stretching or asymmetrical stretching, or meron din yung mga ganun or di kaya ganun, right? So those are the vibrational spectroscopy. You can have microwave, electron spin, and NMR. Now you can have this, what we call typical spectroscopic method. By the end of the semester, you should be able to identify what this instrument is, what this instrument is, and what this instrument is. As of now, if I ask you what are they, you may answer, I don't know. But by the end of the semester, you should be able to tell me that this is a spectrophotometer, this is a spectropolarimeter, and this is an AAS. So as you're going to look at this, they have the same components. Yung tinatawag nating optical components. But the arrangement of the optical components are not the same. They're different. The spectrophotometer, you see the light source here, and then the wavelength selector, and then the sample. Spectropolarimeter, you have the light source here, you also have the wavelength selector, you also have the sample, but the detector that you have here is not in a straight path length as the source compared to the spectrophotometer. Here in the AAS, you have the sample, you have the source, and then you have the wavelength selector. And you may ask why. So by the end of the semester, you should be able to answer that question. Okay? AAS is atomic absorption spectroscopy. It's understandable that you don't know them by now, but to pass the course, by the end of the semester, you should know them. Okay? So this is a typical spectrophotometer. I lose the other photos here. Okay. And then we have the chromatographic methods. And the classic thing that you did in your organic chemistry is you separate, I think, plant pigments. So the history of this is by Tissue-Wet, where we separate this plant extract on what we call column. So chromatography is a method in which the components of a mixture are separated on absorbent column in a flowing system. So the IUFAC definition of that is a physical method of separation in which the components to be separated are distributed between two phases. The mobile phase that is moving over the stationary phase. So you should understand from the word itself, mobile phase, mobile. So it's moving, stationary phase, it's just stationary. Okay. So your stationary phase may be a solid or a liquid supported on a solid or gel, but the mobile phase is either a liquid or a gas, which gives you the name of the method. Gas chromatography, liquid chromatography. There's no such thing as solid chromatography, okay? So this is the classification of chromatography. So on the basis of the interaction of solute and stationary phase, you have adsorption chromatography, partition chromatography, ion exchange, size exclusion. On the basis of the chromatographic bed shape, you can have a 2D or a 3D. So a 3D is a column chromatography, a 2D is either TLC and paper form. Alin dito ginawa niyo sa orgo?
Yung papers.
Paper? Hindi kayo nag-TLC?
Data na lang po yung binigay.
Online setup na po kasi.
Kakaawa kayo. But I think, you know, that online setup is the reason I was able to teach now at UPLB, because I cannot do it in an in-person setup. Yun lang, I think, the advantage. Now, you can also base it on the physical state of the mobile phase. So either you have a liquid chrome, a gas chrome, o yung tinatawag na supercritical fluid chromatography. So you're familiar with supercritical extraction? Anyone? Alam niyo ba yung supercritical fluid? It is the phase wherein even if you increase the temperature or the pressure, it will remain the same. It will not liquefy. So ang tawag natin ay yung supercritical state. Anong everyday application ng supercritical fluid? Anyone? Ha? Uso pa sa Pinas yung tinatawag na dry cleaning? Sorry kasi tagal ko na wala dyan. Kaya nagtatanong ko. Are you familiar with dry cleaning? Ha?
No po.
Ha?
No po.
Hindi?
Yes po.
Meron kasi yung tinatawag na dry cleaner shops. Here in the US, it's common. Now, you may ask, ano yung dry cleaning? I think you can use the word itself to describe it. Anong best way, pag tinanong kita, ano yung dry cleaning? Ano yung sasagutin mo? Anyone?
Hindi po gumagamit ng tubig.
Very good. That's the term. Just like dry ice. Bakit siya tinawag na dry ice? Kasi hindi siya water. Right? Dry ice kasi, yung carbon dioxide, hindi siya pwede mag-exist as liquid sa room temp. If you look at this phase diagram. So sa dry cleaning, you don't use water. What do you use? You use a supercritical fluid, perchloroethylene. Yun yung naglilinis nung libag mo doon sa shirt. Sorry for the term. O yung dumi. Okay? I don't usually use those terms. Kaya masaya ako, at least nakakapag-Tagalog ako magturo. Okay? Because if you're going to look at the principle of cleaning, paano nalilinis nung sabon yung libag mo sa damit? How does soap works? Di ba meron siyang tinatawag na hydrophilic at saka hydrophobic N? So ano yung pagkakaiba nung dalawang yun? Yung isa water soluble, yung isa water insoluble. So ano ba yung mga dirt natin, yung mga libag natin? Ano siya? Water soluble or water insoluble?
Water insoluble.
So usually water insoluble. Tapos ang tanong ko sa inyo, ano ba tayo? Water soluble tayo o water insoluble? Ano tayo mga tao? Water soluble ba tayo o water insoluble? Usually we are water, ano?
Insoluble po.
Water soluble, matutunaw tayo.
Soluble po.
We are water insoluble. If we're going to look at our structure, we are a bilipid layer. So itong ano natin, taba sa labas, tapos sa loob, okay? Merong tinatawag na water soluble component. Tapos taba uli. Okay? So yung dry cleaning, I mean yung cleaning ng soap, usually yung water insoluble niya ang nag-a-act. If you, I don't know where you did this, but I usually discuss this in my Gen Chem. So meron siyang ganon. Tapos yan. So yung maliit na yun, yan yung water soluble. ito yung water insoluble. So kapag nag-a-act sila, so parang inaano nila yung ano bang tawag natin, pinagdidiskitahan nila yung libag or dumi, yung water insoluble component. Okay? So yun yung supercritical fluid. I'm just trying to show you the explanation there. So in the chromatographic methods, meron kang tinatawag na GC or HPLC. So GC is gas chromatography. So it's okay if it's the first time for you to learn the stuff. Yung HP, yan yung tinatawag natin high performance liquid chromatography. And then meron din tayong tinatawag na mass spec, yung tinatawag na mass spectrometry. Although in common the term spectroscopy is not really appropriate to this method, since electromagnetic radiation is not involved in mass spectroscopy. So iba to doon sa spectroscopy. Okay, the important use of mass spec is like in quantitative analysis as gas or liquid chromatographic detector. So detector siya. And it's more, we could say, sensitive compared to the usual detector that you're going to learn. Ngayon, lahat intro lang yan. Huwag kayong ma-overwhelm, okay? Iisa-isahin natin yan throughout the semester. Or iisa-isahin nyo yan sa panonood nyo ng mga recorded video ko during the semester. Okay? So you can have the ICP that is used for metals or elemental analysis. You can have an LCMS, you can have a GCMS. Okay? So if you're going to look at the characterization of metals, so this is the different techniques at ano yung mini-measure nilang quantity, tapos pwede bang single or multi-channel at ano yung principle behind them. So, karamihan maano natin itong tinatawag na Beer's law. Okay? Beer's law is on spectroscopy. So, maybe you're familiar with this one, the calibration curve. Did you do this in 32? Ano yung tinatawag na calibration curve? So, you put a set of standards of different concentration and you try to determine the signal. So what you're trying to do is you find some sort of y equals to mx plus b relationship between the x, which is your concentration, and the y, which is your signal. So what is your m? That's your slope. So once you put there your unknown, you will get the y value, and from the calibration curve, you'll be able to get the x value. So sa calibration curve, meron tayong tinatawag na best fit line or curve to describe the relationship of the analyte concentration and the measured signal. Okay, so usually this one. Is this a good curve? Maganda bang curve na to? Yes or no? Sagot, class. Maganda ba yung curve na yan?
No po.
The answer is no. Because this one. But you can make it beautiful. You remove that one and see ano yung basis natin. Yung R squared. Right? The R squared that is equals to or close to 1 is the best fit line. But don't use 2 points, right? What happened to the R squared when you only have 2 points? Ano yung value ng R squared? It's always 1. Kasi at 2 points will always be what? A straight line. Okay? So, what you're going to do here is you have to know what is the analyte and what's the assay. Analyte is any species whose amount is being determined in a quantitative analysis. an assay is an analytical procedure in which the analyte is the ultimate target. Okay, so this is the commonly used assays that they do to determine bilirubin, calcium, glucose, magnesium, and these are the instrument. And in each of the assay, this is the chemistry and the respective wavelength where you can analyze them. So usually this is patent control. Okay, so the way you do the assay, you look for a stimulus that act as a signal. Okay, or a stimulus that when you put in your sample will produce a signal. So it can be light, heat, current, voltage. You put it in the sample, okay, and you're going to have there a signal that when you convert, you can relate the amount of the analyte in your sample to a certain signal. Okay, so usually when you develop an assay, okay, you have a purpose on doing it. Ano yung pinaka-use assay at this time? Anyone? I don't know if you do it there in the Philippines. Yung COVID testing. That is an assay. What method do they use? Uso pa ba yung tusok-tusok yan na mahaba sa ilong?
Yes po.
Yes,
sir.
Yung pag pumasok sa ilong mo, parang hindi na matatapos. Sa amin kasi dito yung parang cotton buds lang, tapos iikot-ikutin dito sa ilong, yun na. Meron ako nakita ang video parang ginawang halo-halo yung ilong na ang haba-haba, di ba? It's so painful. The last time I did it, sabi ko hindi ko na gagawin. Yung parang, anak ko, tutusok pa lang, umiiyak na eh. 6 years old. But that's the assay that they develop. And they use what? RT-PCR for that. Okay? And we can also look it with respect of when we do methods of chemical analysis. So yung objective natin is whether we perform the classical method or the instrumental method. Usually ang kung available, okay, yung instrumental gawin, kung hindi classical, kung brown out, edi classical. Right? Because I have batchmates of mine who are working in industry here. I always said, do they still do the classical method? They said no. But I'm thinking myself, what happened if there will be no power? Okay. So instruments are important, but solid scientific procedure throughout the method of analysis are necessary. High-end nga yung instrument mo eh, yung sample preparation method mo naman, so. Wala rin. Okay? So if you're going to look at this, the one that I'm trying to show you here is how do you do the chemical analysis? You formulate the question, you select the analytical procedure, sampling, sample prep, analyze, and then report, and then interpret, and then draw conclusion. Or you can do it based on the Harris book here. You select the method, obtain a representative sample, prepare the lab sample, do replicates, dissolve the sample, eliminate interference, measure the property of the analyte, calculate results, and then see if your results is reliable. Okay, so this is where the hard part comes. Or you can do it like that. If I want to check the M&M, the content of caffeine. So what's the difference of this yellow M&M with this brown M&M? The white M&M, okay? And the other thing, tanggal ko ata. Nasaan na yun? So the way that you do it following the chemical analysis method, you select, you acquire the sample, you process it, and then you can ask the question, is the sample soluble? If yes, then you can measure the property. If not, then you dissolve the sample. If the property is not measurable, you react it. You do some chemical change. Okay. You can eliminate interferences, then you measure the property, calculate the result, and then estimate the reliability. Okay. So when you define the problem, why do you measure it? What's the necessary conditions in sampling and sample preparation? What's the best technique for making the measurement? How do you evaluate the data? How do you report the results? And what's the resources needed to accomplish the analysis? So those are the things that you need to ask. Here, whenever you do analysis, you're going to ask this question. What are the things that you're going to consider? So ito, parang ano na to, if you're going to go in depth. Okay? So you have to consider whenever you do analysis. I always tell my student, why are you doing it in the first place? What do you want to get out of this? So there should be planning, modeling, and what we call planning. The model is an idealized representation of the complex steps of this analytical method. Okay? So these are just some. Hindi ko na isahin to because we're going to discuss this stuff when we go there. Obtain and store the sample prep, and then perform sample analysis. And you can use the standards. The strength of your chemical analysis depends on the standards. Because when you do analysis, you're just comparing the signal of known standards compared with the sample signal that you get. Okay? Kaya napaka-importante nung tinatawag nating standards. So I think that's it. And the last thing that I could ask you maybe in the near future, so ang tinatawag natin, I think some of you will end up with this one. What is that? There's a lot of microplastic that is present, and I think Dr. Pradejas is a research on that. Here in our country, we have what we call how clean is your tap water. So maybe you can put a database out of it. So for instance, if I go there, it will going to bring me to a website. I hope it's open, EW.org tap water. So let's see. I can always show you what that website is. So EW. So usually what they do, they will show you the tap water that you have. I don't want this one. No, I cannot. Maybe some other day I can show it to you. Okay. Or maybe, I'm not sure if you're familiar with the Theranos case. So the way that they try to sell it in the Theranos case is instead of using this amount of blood, you just need this amount to tell what you have in your blood. And unfortunately, as of now, the technology is not yet on that level, but we're on the way. This is something to do with microfluidics. Maybe you will be the one who is going to do this. Okay. Now, take-home messages I usually do is everything is made of chemicals. water is a chemical per se, and the dose makes the poison. So what does it mean? If you have too much chemicals, you can die of it, even water. And there's really no difference with the natural or synthetic version. What's the issue that we have with this natural and synthetic version there in the Philippines? Anyone? Ano yung naging issue noon? Na lahat ng gamit na to or product na to ay synthetic. Yung suka, di ba? Narinig nyo ba yun? Hindi yata kayo ano nangyayari sa paligid nyo eh. Okay? And this one, natural chemicals are not automatic and artificial chemicals are not automatically bad. Just imagine, you can die from eating cassava because they can produce what? What's the natural toxic materials that cassava? Ano tawag natin sa cassava sa Pinas?
Kamoteng kahoy.
Kamoteng kahoy. Ano yung chemical na toxic na na-produce doon?
Cyanide.
Cyanide. Okay? And not all artificial chemicals are bad. So if ever, let's say, during the celebration last time, you don't want to spend too much of the rose petal for a drop of that sweet smelling chemical when you can synthesize them in the lab. Okay? And usually a chemical's property are determined by the other chemical that it is bound to. So NaCl has a different property from just Na and Cl2, right? Explosive, toxic, when you combine them, you eat them. Right? Because I think the anti-vaccine before, they don't want it because they said there is a mercury metal, but it's not really a mercury metal that you have there. It's a mercury form that is attached as a compound. Okay? So dito nag-end yung preliminary ano natin. So what I want to do is, asan na yun? On Thursday, oh no, not Thursday, on our next meeting, if you have time, I want you to attend this one. Have you heard about this?
Yes po.
Yes po.
I think the talk that you will have is relevant to our course. I want you to attend that because that speaker is an alumnus of UPLB, and that speaker is my PhD advisor. So that is between before we meet. I'm not sure. Maybe when you attend there, what do you think? Do you think we still meet next meeting on Friday, or I can rely on you, or you'll be responsible enough to watch the videos? Because all of the videos that we have, so I have to log out from this. Oh, meron nag-email sa akin. Oh, yeah, may gumawa na ng mga introduction. So I try to go to the YouTube, but I have to use another account in that YouTube. But I'm going to send the link for this, what we call video. Ano kasing password? Because I tried to tag them, but usually, see this thing? So these are all 137. So I think the same thing that we have there is this one, doing chemical analysis, and then the first meeting that we have there, 921. So like method validation thing. But I'm going to put the link on that once I finalize the canvas. So tanong, may bakante pa doon sa isang section kung gusto niyo lumipat. Kasi maraming gustong lumipat dito, hindi ko alam kung bakit.
Masaya na po kami dito, sir.
Isang beses pa lang tayo nag-meet, masaya na kayo. Darating ang time pag alas 12 na yung ano ko. O yung pag alauna na yung tapos natin talagang inaantok na ako. Kasi Gian, galing yan sa kabila, di ba, Gian?
Yes po, sir.
Yung isa tatanggapin ko na tapos sinabi niya, ay, may slot po ako sa section B. Sabi ko, oops, stay ka dyan. I don't know. Okay. The technology is good, but it has to be, we could say, validated and perfected. I know it works during that time. Nabigla lang ako, sigurado ka. Magiging scam lang. And that's really what happened. Because they what we called scam a lot of investors. Ang problema nga, yung mga investor, mga big names pa. He was able to have a raise funds around 10 billion, if I'm not mistaken. So yun yung ano namin dito. I read the book about her, and I think there's a movie with Jennifer Lawrence as the lead actress. I don't know when it will come out. Okay, so that's the thing that you have to be worried, because there's also a case, because we have a forensic science program in Pace University. May isa namang chemist na nagpa-impress, nag-ano siya ng, I think, several cases, and they found out that he's just lab dubbing. Hindi talaga niya ina-analyze yung sample. Sinasabi lang niya, oh, meron niyang ganyan, ganito kadami. So around 20,000 cases has to be what we call re-evaluate, and they have to drop that cases because of the anomalous chemical analysis that was done by the chemist. So question. Kung available kayo, then attend. Okay? And we will see. Gusto niyo bang mag-meet? O sino pala na umalis na lahat? Sino mag-aano sa Facebook? Magano nung group? Ng group chat. Meron ba dito kilala lahat?
Ako na lang po, sir.
Ha?
Ako na lang po.
Ikaw na lang. So, i-ano mo sila. Okay? Yung name ko, Elmer Moica, I think some of the UPLB students has me as a friend, so you can invite me on that. Okay? Ikaw na bahala, Manel?
Yes po, sir.
Okay. So, may tanong pa? So, kung wala na, we will see on the chat kung mag-meet tayo sa Friday. But I expect to see you on the what we call webinar. Okay? So if not, magandang tanghali or hapon sa inyo dyan. Alam ko gutom na kayo. So sa uulitin sa next meeting natin.
Thank you po, sir. Good night po sa inyo
Thank you
dyan.
po.
sir.
Good night po.
Thank you, sir. Good night
Tulog
po.
na po kayo, sir.
Alas 12 pa lang.